the directions on this one are to solve the equation, and so we need to solve for x. And this side, actually, when I wrote it down, I was sort of beginning with the end in mind, and I put parentheses around it, and it actually doesn't have parentheses in the original problem. Anyway, so that right side looks sort of normal. It's that left side that the x is trapped. It's trapped inside of a square root. I can't go subtracting 10 and dividing 9 right now because x is trapped inside a square root. Well, how do you undo a square root? You square it. But what you do to one side, you must do to the other side. So on that left side, we just have 9x plus 10. It looks great. Our life is good. But on the right side, you have x plus 2 squared, and we have to now simplify that out. And you're like, whoa, I had a square root, and now I have something squared, so how did I make it look any better? Well, I can simplify x plus 2 squared. Now, it's not simply x squared plus 4. You're not squaring the x and squaring the 2. You're squaring x plus 2. And so when you square something, that means to multiply it by itself. Think about 9 squared, for instance. 9 squared is 81 because 9 times 9 is 81. So x plus 2 squared is x plus 2 times x plus 2, and you had to simplify that out to get x times x is x squared, and x times 2 is 2x, and now 2 times x is 2x, and 2 times 2 is 4. To get x squared plus 4x plus 4 equals 9x plus 10. So at this point, we have I guess the whole time we have a quadratic, meaning the highest power in this thing is 2. We're going to have 2 answers. Whenever I have a quadratic, I like to put it in the form of ax squared plus bx plus c equals 0. I like to put everything on one side. Whether what I just wrote down, everything's on the left side and 0 is on the right. But in this one, x squared is on the right side, and x squared is also positive right here on the right side. If I moved x squared and 4x and 4 over to the left, it would be a negative x squared, and I just don't like negative x squared. So I am going to subtract 9x and subtract 10 from both sides to get that 0 equals x squared minus 5x minus 6. So I had to solve this quadratic, x squared minus 5x minus 6, and looking at it, I know it factors. The factors of negative 6 that add to give you negative 5 are x minus 6 and x plus 1. Negative 6 and positive 1 multiply to give you negative 6. They add to give you negative 5. However, if you're not that strong in factoring, we can always use the quadratic formula to solve a quadratic. Always. I suggest perfecting it because you can always use it. It's the safest route. See, some quadratics that you get are unable to factor. We would call that prime. You would not be able to do this. And so that doesn't mean that you can't solve the quadratic. You would then be forced to plug it into the quadratic formula. But the quadratic formula works for things that factor as well. So if you're uncomfortable doing this, plug it in here. So once you factor it, just set each factor equal to 0. So x equals 6 and x equals negative 1. What you would want to do at this point is plug those answers in to make sure they're correct. On this test, when you're dealing with rational equations and equations with square roots and things like that, you do want to make sure your answer is true. Sometimes you get an answer that you cannot use. So over to the side, I'm just going to check it. The square root of 9 times 6 plus 10 equals 9, not 9. 6 plus 2. So I plugged in the 6 and the answer 6 works. Let's just plug in the -1 really quickly. And that is a true statement as well when we plug in -1. So I'm going to teach a little bit of a trick on number 7. But let's talk about, the directions say to solve by completing the square. But let's talk about what you have here. You have a quadratic. There are 3 ways to solve a quadratic. One being to factor it, but factoring doesn't always work, right? The other way being completing the square, which this is asking us to do. But sometimes completing the square just is not fun or either not efficient. And then you can always use the quadratic formula, always. So that's my tip for you. If you are uncomfortable completing the square or factoring, just plug it into the opposite b plus or minus the square root of b squared minus 4ac all over 2a. And while that may not be fun either, you can always use it, okay? But since this one says solve by completing the square, that's what I will do. I start off by moving over that 3 on the end. I call it the c term, ax squared plus bx plus c, to where I'm just having the variable squared and the variable on the left side. And you can see where I left myself plenty of room. So what we're going to do now is take the number that has the variable to the first power. It's the b term, so 14 in this case. We're going to half it and square it and add it to both sides. Half of 14 is 7. 7 squared is 49. We're adding 49 to both sides. What we have done, first of all, this equation is equal to this one. We're making it look different. We're manipulating it. We have created a perfect square trinomial right here. And a perfect square trinomial, the reason we created it is because it factors very easily. Because think about factoring something. You're looking for something that multiplies to give you this and adds to give you this. 7 and 7 multiply to give me this and add to give me this. It will always be when you factor a perfect square trinomial, and that's what it will be when you complete the square because you created it. It'll always be half of this number in sign. So instead of writing it as c plus 7 times c plus 7, that is correct. That's a correct way to write it. We're going to write it as c plus 7 squared, because when you multiply something by itself, it is squared. And then I can use the square root property to solve it. That's a 2, by the way. Anyway, so now let's apply that square root property, taking the square root of both sides. The square root undoes the square to leave me with c plus 7. And when you inflict something on something else, there's positive and negative consequences. So when I inflict a square root on something, on a number, it's like inflicting a disease. There's a positive and negative square root of 52. I do want to go off to the side before I go any further. To solve for c now, all I got to do is subtract 7 from both sides. But I do want to go off to the side and see if the square root of 52 reduces. All the prime factors of 52. 52, 2 goes into it 26 times, but 26 is not prime. I'm not going to write it down. 2 goes into 26 13 times. 13 is prime, so I can stop. The square root of 52 is equal to the square root of 2 times 2 times 13, because 2 times 2 times 13 is 52. And there's a group of 2 right here. So bring that 2 out front and leave what doesn't repeat twice inside. So c plus 7 equals plus or minus 2 square roots of 13. And now all I need to do is subtract 7 from both sides to get c equals negative 7 plus or minus 2 square roots of 13. Okay, so we got the absolute value of 6x plus 3 plus 6 less than 4. Whenever you're solving, so we got two things that we're dealing with here. We're dealing with an absolute value and we're dealing with an inequality. Before I solve this inequality, I gotta solve for x, and before I can get to x, I have to isolate the absolute value. I gotta get the absolute value by itself. So real quick, I'm gonna subtract 6 from both sides to get negative 2, and I have the absolute value of 6x plus 3 is less than negative 2. So at this point, to get rid of the absolute value, copy paste the 6x plus 3, I copy paste the less than, and I copy paste the negative 2, and I must create another inequality. The second inequality will be 6x plus 3, but for this one you must flip the symbol and you must change the sign of the number on the end, so it'll be a positive 2. And let's talk about and this is now this is a compound inequality. And compound inequalities are either worked as an and problem or an or problem. And problems look for overlap. Let's change colors. And looks for overlap. And or looks for gaps. Okay. Now, this one didn't come out and tell us if it was an and or an or problem. So we must know if it starts off as a less than is and if it starts off as greater than, it's an or problem. So let's finish working these out. Subtract 3. Divide by 6. X is less than negative 5 over 6. Divide by 6. So, the way it asks for this, it just depends on the question. It's going to ask you more than likely for the interval notation and for the graph, and it may do those in any order. Before I answer that on the computer, though, I like to sort of get my answer myself on my paper, and I start with the graph. And so you got to put negative 5 over 6 and negative 1/6 in the correct numerical order from left to right. Negative 5 over 6. 5 over 6 is the decimal negative 0.83 repeating, and 1 over 6 is the decimal negative 1.6 repeating. So negative 5 over 6 goes before negative 1 over 6. The numerical order is pretty important, and let's graph this out. So let me use a highlighter. Negative 5 over 6, x is less than negative 5 over 6, so that's going in the left direction. Wait, that highlighter is janky. Sorry. going in the left direction, and we're going to have a parenthesis because when it's just less than and it doesn't have the or equal to symbol, the flat or equal to symbol, I don't have a flat bracket there, okay? And now on the other one, x is greater than negative 1/6. It will go to the right and again have a parenthesis. So was this an and or an or problem? This was an and problem. And looks for overlap. So we're wanting to see where these two light blue graphs that I just graphed overlap at, and they never overlap. So in this case, your answer is an empty set. No solution. Because they never overlap. Now, had this been an or problem looks for where there's a gap at, and there's a gap right here. So your answer from left to right would be, where is there basically not a gap, and where is their graph? And so there's graph starting here and it ends here, and starting back up here and ends there. Well, starting at this arrow to the left would have been negative infinity that goes all the way to negative 5/6 and then picks back up at negative 1/6 and goes to infinity. But that's not the answer because this wasn't an or problem. This is the answer. Well, number 10, we are solving the equation. Let's just take a quick look at this thing. I like that it said equal to 0. That makes me feel happy for some reason. But looking at it, I mean, we've solved a lot of quadratics, but quadratics have a highest power of 2 of something squared, and this is a cubic. We don't have a cubic formula like we have a quadratic formula. But if you think about solving quadratics and how you can factor them, if you can factor the cubic, then that works as well. But it's 4 terms. It's not a trinomial with 3 terms. It's 4 terms. Well, the way you factor something with 4 terms is to group it. It's not bad at all. You just group the front and the back, okay? And now if I were in person and could put my hand over it, I would literally put my hand over this right now, okay, and forget about it and just look at this, the front binomial that we've created, that we've grouped off, and look for a GCF between 45q cubed and 36q squared. And you heard me almost say 9 right there because I'm looking at 45 and 36, and a 9 can be pulled out from those two numbers. And then a q cubed and a q squared, you have a q in both. So take out the lowest power, and the lowest power we see is squared. So now to get what is left, you want to say 45q cubed divided by 9q squared. To get 45 divided by 9 is 5. And q cubed divided by q squared is just q. You're taking 2 q's away from 3, and you got a factor of q left. And now 36 divided by 9 is 4, and q squared divided by q squared cancels, and you don't have to worry about it anymore. So now at this point I would take my hand off of this one because I was covering it up for myself, and I would put my hand over all of this and focus on this guy, okay? So a GCF between negative 5q and negative 4. Now there's not really what I call a GCF. And in that case, when there's not a GCF, just pull out a 1 and write down what you see. However, the leading coefficient is negative, and I don't like that, so I'm going to pull out a negative. So a negative 1, and you would just be left with the opposite. The same thing, just with opposite signs. So a positive 5q and a positive 4. And look, what we were left with in both cases is the same exact thing, and that's actually what's supposed to happen. If that didn't happen, we probably messed it up somewhere. So since they're the same thing, I can take it out. And when I take it out, you're literally left with 9q squared and negative 1. And I'm trying to turn my 9 into a q. Okay, so I have factored by grouping. And honestly, I could get my final correct answer from this. It is not fully factored though. And here's one reason why I'm kind of picking up on that. Because this was a cubic, meaning we're going to have 3 answers. And there's only 2 factors, and a lot of times that just means 2 answers. Well, if I ended up setting 9q squared minus 1 equal to 0, I would just say 9q squared equals 1. I would divide by 9, and I would have to use the square root property to get q instead of q squared. So there would be my 2 other answers. And then I would just get one answer from 5q plus 4. So yes, you can set both of them equal to 0 just like they are, but I am going to fully factor it. 5q plus 4 did not factor any further, but 9q squared minus 1 is a difference of squares. 9 and 1 are perfect squares, meaning I can take the square root of them, and it's a difference of squares because they're subtracted. So there's a formula for that. If you have a squared minus a b squared, it's a plus b times a minus b. So the square root of 9q squared is 3q, and the square root of 1 is 1, and so 3q minus 1. And now you can set all 3 of these equal to 0. Now, are the answers pretty? Probably not. I mean, they probably look scary because a lot of people don't like fractions. But I mean, I think they're pretty.